Very good morning to all of you. Today I want to explain experimental 1 of Environmental Engineering Laboratory. Title of the experiment is Preparation Chemical Solutions Required for Analysis and Sampling Methodologies of Module 1, Experiment 1. Course outcome: acquire capability to conduct experiments and estimate the concentration of different parameters. Subject title is Environmental Engineering Laboratory. Subject code is 18CVL67 of 6 semesters in civil engineering departments. This table is explained in details how to prepare chemical solutions required for analysis and sampling methodologies. Experiment number 2A. Title of the experiment: determination of pH. Which are the reagents are required for this experiment? Dissolve buffer tablet of pH 4 in 400 ml of distilled water to get pH 4 buffer solution. Similarly, other buffer solution can be prepared by dissolving corresponding buffer tablets of pH 7, pH 9, etc. For experiment determination of conductivity, reagents are required 0.01 normality KCl solutions. So for this reagent, dissolve 0.746 grams of potassium chloride in 1 liter of distilled water. Now it's becomes the conductivity should be 1413 micromoles at 25 degrees centigrade temperatures. And for the determination of TDS and turbidity experiments, reagents are required. Here there are two phases. One is stark turbidity suspensions. In this, solution 1 is required. How to prepare this solution 1? Dissolve 1 gram hydrogen sulfates in distilled water and dilute to 100 ml in a volumetric flask. And solution 2, dissolve 10 gram of hexamethyl tetramine in distilled water and dilute to 100 ml in volumetric flask. Next step, in 100 ml volumetric flask, mix 5 ml solution 1 and 5 ml solution 2. Let them stand for 24 hours plus or minus 3 degrees centigrade. Dilute the solution mixture up to the mark. The turbidity suspension now has a turbidity of 400 NTU. Prepare the solution and suspension weekly. Next, standard turbidity suspensions is prepared. Dilution of other values can be prepared from this 400 NTU solutions by the following successive methods. Here, if for 200 NTU, take 50 ml suspensions, take 50 ml distilled water. Now it's become 200 NTU. For 100 NTU, take 25 ml suspension, 75 ml distilled water. Now it's become 100 NTU. For determination of acidity experiments, these are the reagents are required. Standard sodium hydroxide 0.05 normality. To prepare this reagent, dissolve 2 grams sodium hydroxide in 50 ml distilled water. This 50 ml is made up to 1 liters. Next, sodium thiosulfate is required, methyl orange indicator is required, carbon dioxide free distilled water is required. So these are the reagents are required for determination of acidity. Next, determination of alkalinity. These are the reagents are required. Standard sulfuric acid 0.02 normality is required. So how to prepare this solution? Prepare 0.1 normality H2SO4 solution by diluting 3 ml concentrated H2SO4 to 1000 ml. Dilute appropriate volume of hydrogen sulfate to 1000 ml distilled water to obtain standard 0.02 normality sulfuric acid. Next, phenolphthalein indicator is required and methyl orange indicator is required. These are the already prepared and purchased and procured for execute the experiments. Next experiment, determination of calcium magnesium hardness by EDTA methods. So for this, these are the reagents are required. EDTA salt is required of 0.01 molarity. So here To prepare this EDTA 0.01 molarity reagent, dilute 3.723 gram of EDTA salt and dilute to 1000 ml double distilled waters. Next, sodium hydroxide is required, so of 1 normality. So to prepare this sodium hydroxide, dissolve 40 gram of sodium hydroxide in distilled water and dilute to 1 liters. Now it's become sodium hydroxide 1 normality reagent. Next is murex indicator. It is already available from the prepared company. Next, how to determine total hardness by EDTA methods. To complete this experiment, these are the reagents are required. EDTA 0.01 molarity is required. So for this, dilute 3.723 gram of EDTA salt and dilute 2000 ml distilled waters. Now it's prepared 0.01 molarity EDTA solution. Buffer solutions. How to prepare this buffer solution? Mix 6.75 gram of NH4Cl methyl chlorides, ammonium chlorides with 57 ml liquid ammonia and dilute to 100 ml with the distilled waters. Now this become buffer solution. Erichrome black tea indicators. Use ready powder or prepare as follows. Mix 0.5 gram solochrome black dye with 100 gram sodium chlorides to prepare dry powders. Now this becomes Erichrome black tea indicators. Determination of dissolved oxygen by azide modification methods. So for this experiments, so these are the reagents are required. Manganese sulfates. Dissolve 72 gram of manganese sulfate in 150 ml distilled waters. Now this become manganese sulfate solution. Azide reagents. Mix 30 gram Ki, 100 gram potassium hydroxide and 4 gram sodium nitrite and dilute it to 200 ml distilled water. Now it's become azide reagents. Next, procured concentrated sulfuric acids. Next, starch. Next, sodium thiosulfates N/14 normality. Now to prepare this, dissolve 6.205 gram of sodium thiosulfate and dilute to 1000 ml distilled waters. So these are the reagents are prepared to complete DO by azide modification methods. Next experiment is determination of chlorides. So for this experiments, these are the reagents are required. Silver nitrates. Dissolve 2.395 gram silver nitrate in 1000 ml distilled waters. It's become 0.0141 normality silver nitrate reagent. Next, potassium chromate reagents. Dissolve 5 gram potassium chromate in 100 ml distilled water. Now it's become potassium chromate solution after complete dilution. Next, determination of percentage of chlorine in bleaching powders. To complete this experiment, these are the reagents are required. Sodium thiosulfates of N/14 normality. Dissolve 6.25 gram of sodium thiosulfate in 1000 ml of distilled water and dilute. Add about 5 ml chloroform as a preservative. Now it's become sodium thiosulfate. Bleaching powder solution. Dissolve 0.5 gram of bleaching powder in 200 ml distilled water and dilute it completely. Now it's become bleaching powder solutions. Potassium iodide solution. Dissolve 5 gram potassium iodide in 100 ml distilled water and dilute it completely. Finally it becomes potassium iodide solutions. Next, glacial acetic acid is this. Next, freshly prepared starch. So this is following procedure to prepare freshly prepared starch. Dissolve 2 gram of LR grade soluble starch in distilled water and pour this emulsion into 100 ml of boiling water. Allow to boil for few minutes. Add 0.2 gram of salicylic acid or toluene as preservative. Cool this solution and then use. Now this becomes freshly prepared starch. Next, for determination of residual chlorine experiments, so these are the reagents are required. Sodium thiosulfate of N/14. So same steps of above experiments. Dissolve 6.25 gram of sodium thiosulfate in 1000 ml of distilled water and dilute. Add about 5 ml chloroform as a preservative. Now it's become sodium thiosulfate solution. Potassium iodide. Dissolve 5 gram Ki in 100 ml distilled water and dilute. Now it's become potassium iodide solution. Next, glacial acetic acid. This is readily available from the markets. Freshly prepared starch. Same steps. Dissolve 2 gram of LR grade soluble starch in distilled water and pour this emulsion into 100 ml of boiling water. Allow to boil for few minutes. Add 0.20 gram of salicylic acid or toluene as preservative. Cool this solution and then use. So now this becomes freshly prepared starch. Then conduct the experiments. Next experiment, determination of chlorine demands. So for this experiments, reagent is required standard chlorine solutions. To prepare this standard chlorine solution, dissolve 0.5 gram of bleaching powder in 1000 ml distilled water and dilute it completely. So now this becomes standard chlorine solution. Then execute the experiment. Next, how to determine optimum alum dose by jar test. To conduct these experiments, so this is reagent is required, that is 1% alum solution is required. To prepare 1% alum solution, dissolve 1 gram of alum that is powdered in 100 ml distilled water. So this is the reagents. Label it and continue the experiment. Determination of iron by microprocessor spectrophotometers, iron and nitrates by microprocessor photometers. These are the reagents are required for these experiments. Hydrochloric acids. Next, hydroxylamine hydrochloride solution. To prepare this, dissolve 10 gram of methyl hydrochloride in distilled water and dilute it 100 ml of distilled water. Next reagents, ammonium acetate buffer solution. Dissolve 250 gram of NS4C2H23 in 150 ml distilled water and add 700 ml of glacial acetic acid and solution. The solution is dilute to 1 liter with distilled water. Next reagents, phenolphthalein solutions. To prepare this, dissolve 100 mg 110 phenolphthalein monohydrate in 100 ml distilled water and 2 drops of concentrated HCls. Now it's become phenolphthalein solution. Stack iron solution. Add 20 ml concentrate H2SO4 to 50 ml distilled water and dissolve 1.404 gram of ferrous ammonium hydroxide. Add dropwise 0.1 normative potassium permanganate till faint pink color persists. Dilute to 1000 ml. Next, standard iron solution is required. To prepare this standard iron solution, dilute 50 ml stock iron solution to 1000 ml. Prepare this freshly 1 ml is becomes 10 milligrams irons. So these are the reagents are required to determine iron content. Next, how to determine COD, determination of COD. So this experiment is demonstration, but now no problem, I will just explain how to prepare the reagents. Standard potassium dichromates 0.25 normality. Dissolve 12.259 gram potassium chromate in distilled water and dilute to 1000 ml. Next, COD reagent is required. To prepare this COD reagent, add 22 gram of silver sulfate to 4 kg of sulfuric acid and keep overnight for dissolutions. So now it's become COD reagent. Standard ferrous ammonium sulfate. Dissolve 39 gram of standard ferrous ammonium sulfate in 400 ml distilled water. Add 20 ml concentrated H2SO4 and dilute to 1000 ml. Now it's become standard ferrous ammonium sulfate reagent solution. Next, mercury sulfate. Next, ferrine indicators. So these all are available readily on markets. So these are the MCQ prepared from all the last slides discussed. Okay. So here 4 options are given and correct answer is also given. Question number 1. The permissible range of pH value for drinking water is option 6.5 to 8.5 or 6 to 8 or 7.5 to 12 or 7 to 14. Correct answer is 6.5 to 8.5. The permissible value of acidity in milligram per liter for drinking water is 25, 30, 50, 100. Correct answer is 50. The permissible value of alkalinity in milligram per liter for drinking water is option 150, 100, 110, 200. Answer is 100. The permissible value of calcium in milligram per liter for drinking water is 300, second 100 or 125 or 185 milligram per liter. Correct answer is 300 milligram per liter. The permissible value of total hardness in milligram per liter for drinking water is option is 500, 600 or 700, 200. Correct answer is 600 milligram per liter. The permissible value of chloride in milligram per liter for drinking water is 250, 260, 270, 280. Answer is 250 milligram per liter. The permissible range of total dissolved solids in milligram per liter for drinking water is 500 to 2000, 500 to 1000, 400 to 500, 600 to 800, 500 to thousands. So correct answer is 500 to thousands. The permissible value of turbidity in NTU for drinking water is less than 5 or less than 20 or less than 10 or greater than 10. Correct answer is less than 10. The permissible value of iron content in milligram per liter for drinking water is 0.322 or 0.2 to 0.6 or 0.8 to 1.1 or 0.3 to 1. Correct answer is 0.3 to 1 milligram per liters. The fresh bleaching powder will have chlorine in the range of 10 to 20% or 25 to 30% or 50 to 75% or 100 to 125%. Correct answer is 25 to 30%. So these are the references or reference for to prepare all reagents required to concerned experiments. Thank you one and all. Next class I will continue.